This is a tricky question and it has been asked quite a few times in Amazon and Facebook interviews, and also it has been asked in Apple, Google and Microsoft. So in this problem we have to find all the duplicates in an array. So let's see more about this array. This is not just like a normal array, it has some special properties. So first I will explain the problem, then I would recommend you to pause the video, think for a while and then try to come up with a solution, and then try to match with this solution, or maybe that you are not able to find the optimum solution, so you can continue from there. So just pause for a moment, think about it and then come back. So the problem is that we are given an array and all the numbers in this array are more than 0, that is 1 onwards, and the size of array is n, and the numbers are also from 1 to n. So this is the special property that differentiates from just a random array. Size is n and its numbers are from 1 to n. So as a concrete example, if you look at this array, its size is 8. 1, 2, 3, 4, 5, 6, 7, 8. And if you look at individual numbers, none of them will be more than 8, none of them will be less than 1. So some numbers appear once. So let's say there are 8 elements and their range is from 1 to 8. So if each number appears once, then we will have exactly 1, 2, 3, 4 all the way up to 8, each appearing once. But some numbers are occurring twice and others are occurring once. There is no number that occurs 3 times or 4 times. So we have to find all the duplicates. For example, in this case, 1 is there, 2 is there, 3 is there, 4 is there, 5 is not there, 5 is missing, 6 is missing, and 7, 8 is there. So 2 numbers are missing. That means 2 numbers have appeared in place of them. So 2 numbers must be occurring twice, and those numbers are 2 and 3. So if you remove these, we have 1, 2, 3, 4, 7, 8. Each number will occur once. So here we have to return 2, 3. So how can we do that? One query is that you have to do it in without any extra space and in O of n runtime. So if this is just some normal array without this property, then you can do it in O of n and O of n space. If you use a hash set, you just iterate through it, keep pushing them into the set, and if you encounter it again, then you know that that has already occurred. For example, you put 4 here, 3, then 2, then 7, then 8, then when you are here, you see that 2 is already present. So you add 2 to the result. So this will work for any general array with O of n and O of n space. But here we have to do in O of 1 space. In some general array, you can also sort them in O of n log n time, and then iterate through that sorted array and all the duplicates will appear together. So their space is O of 1, but time is O of n log n. So we have to do the best of both. That is time of O of n and a space of O of 1. So let's see. So clearly we have all the numbers from 1 to 8 and the size is 8. So the indices of this array will be from 0 to 7, n minus 1. So these are indices. Indices are from 0 to 7. Actual numbers are from 1 to 8. So if you subtract 1 from these actual numbers, then those will represent a valid index in this input array. Let's call it A. So we can use this property. So these numbers are nothing, but they are denoting some index if you just subtract 1 from them. So if we have duplicates, for example 2, then that means the number, so we can treat them as just index, and that is the purpose of this question for giving this property, that numbers are from 1 to n and indices are from 0 to n minus 1. That is the main hint that is given through this. So what we will do, let's write the indices. You can write 0 to 7 or you can write 1 to 8. So let's say write 1 to 8. In the code we will just subtract 1 from them. So 1, 2, 3, 4, 5, 6, 7, 8. So this is first element, second element, third element, fourth, and so on. So when we see 4, we will go to 4th place and make them negative. All of them are positive, all of them are more than 0. So we make this negative. So now this becomes minus 7. Let's get rid of these. Next is 3. So we go to 3 and make it negative. We multiply by -1. So if we reach at an index second time, we will find that the number is already negative and we are trying to negate it again. So that means it has already occurred. That's why we came here earlier and made it negative. We are making it negative second time. So it's a duplicate and we will add this value to the result. Now we come here at third position, it's -2. So we have to take absolute value since the indices can never be negative. So 2 is there. So go to 2 and make it negative. Then we come here 7. So go to 7th index and make it negative. And then we come here. So we come to 8th position and make it negative. Then we come here, go to second position, make it negative, but it's already negative. So we add this value into the result, that is 2, and make it negative, that is 3. Or you can leave it as it is, it does not matter. Since we will never reach it here again, since we reached here for the second time and a number can occur at max second time. So whether we make it positive or not, it's up to you. Next, we will come here. So we come here, 3 is there, go to third element, make it negative, but it's already negative. So this is also occurring second time, 3. Then we come here, go to 1, make it negative. So we have reached till the end, we have iterated all the numbers, and this is the result, and we will return it. So let's write the code for this in all the 3 languages. So the return type is vector. So we are iterating through this nums, n is the actual number, and we will take absolute value of this. Since if we have negated some value, so we were at first position and we were holding a value of 3, so we went to the third place and made it negative. So when we reach that position, this number will be negative. So that will be some invalid index. That's why we will always take negative. But we will compare the value. If it's negative, that means it's duplicate. If nums n minus 1. So remember that these numbers n is from 1 to n, in this case 1 to 8. But the index is from 0 to 7. So we will always subtract 1. So if it's greater than 0, that means we are reaching here for the first times. Multiply by -1. Else, if this is negative, that means we are reaching here for the second time. So result dot push back n. And finally, return result. So it's very simple. And the solution is accepted. And you can see the time taken would be O of n, since we are iterating this for each element in this nums. And space, this result is not counted as extra space. You don't have to use extra space, but this is the actual result which we have to return anyway. There is no escape from this. So we will not count this space. So otherwise we are not using any space other than this n. So it's O of 1 space and O of n time. Now we will write the same thing in Java and Python. So return type is list integer. So we are converting n to absolute value, since if we are at some earlier index and holding a larger value, we go there and made it negative. So once we reach there, that n can be negative, which will not be a valid index. So we make it absolute. If nums n minus 1 is greater than 0, then nums n minus 1, we multiply by minus 1. Else, if it's already negative, that means we have already reached here once and we are reaching here second time. That means it's a duplicate. And the Java solution is also accepted. Finally, we will write it in Python 3. And the Python solution is also accepted.